Welcome to Coffee and a Quickie, another short supplemental video for the Wireshark Network Analysis book. This is Laura Chappell, and in this video I'm going to take you through some of the book elements. We're going to focus specifically on the two types of filters that are available with Wireshark, capture filters and display filters. And I want you to keep in mind the comment that I have throughout the book about using capture filters sparingly but using display filters liberally. Capture filters are covered thoroughly in Chapter 4, whereas display filters are covered thoroughly in Chapter 9. In this section of the book, these two chapters of the book, you'll learn why you can't apply a capture filter to a trace file that you're pulling up off of a hard drive. So capture filters are only used at the time we're doing a live capture, whereas display filters can be applied while we're capturing traffic, or they can be applied to a saved trace file. The purpose of using filters is to reduce the amount of traffic that you have to wade through to try to find the packets of interest. We can either do an inclusion filter, which means that we want to include or see certain traffic, such as maybe you build a filter for traffic to and from Fred's IP address. But we also have exclusion filters, which is when we say we want to exclude something or not see it. So we might say that we want to see all traffic except for UDP traffic. Let's go over to Wireshark and start building some filters. Wireshark includes a set of default capture filters and display filters, and you can take a look at those up on the toolbar by clicking on the Edit Capture Filter button or the Edit Display Filter button. So I'm going to open up the default set of capture filters. There they are, and this is nice because if you're not sure of the syntax, you can use one of these examples and build a filter based on these. In Wireshark, there's no error detection mechanism built in when you're creating your capture filters. It's only when you create one that's incorrect and you try to apply it that Wireshark will sort of barf at you and tell you that, that's impossible. You can't do that. If I look at one of these capture filters, for example, the very first one on the list, we can see the basic syntax is ether space host space, and then there's the MAC address of the host whose traffic we'd be interested in. If I want to capture only TCP traffic, we can see that the filter string is just TCP. Now, capture filters and display filters use different syntax, but in a couple of places, such as TCP or UDP or IP or ICMP, they both use the same syntax. But again, there's no error checking mechanism available to us. So if we type in an incorrect filter syntax, maybe I'll do IPv6 because I want to capture all IPv6 traffic, and I believe that that's the filter. When I try to apply this type of a capture filter, I'll get an error message that comes up. Let me generate one of those. So I'm going to look at my interfaces to see what's available. And I think I'll be looking at the traffic using my native wireless adapter. I'll go to the options area. And in the options area, this is where we are given the option to put in the capture filter to define what we actually want to capture. Again, use this sparingly because if I put in a filter for just IPv6 traffic and then I find that, oh shoot, I wish I had looked at the IPv4 traffic, it's too late, it's gone. So I'm going to type in this incorrect filter syntax and then I'll just start the capture process. And we can see that Wireshark says, that's an invalid capture filter. It doesn't give us that information while we're doing the creation of the capture filter. It only tells us that unfortunately, when we launch the capture process. So the correct way to do an IPv6 filter would be in the options area again. We're just going to select or type in IP6. I know it looks like it's a typo, but it's not. And I'll go ahead and start, and we can see that that's acceptable. Any packets that have an IPv6 header would be captured by this filter. We're not using IPv6 on the wireless network, so I'll stop capturing, and it tells me that there have been no packets captured. It also points me to the Capture Setup wiki page. Another way to get to the options area is just from the main start page. You can just go directly to Capture Options. Or up here on the toolbar, you can go to the second icon over. Open that up, and it takes you right into the options area. Now, I'm not interested in doing IP version 6 as a capture filter, but what I will do is a simple capture filter for ARP traffic. I'm just going to type it in because I know the syntax, but if I didn't know the syntax, I could click on the Capture Filter button and just see those default capture filters. Now that I have ARP listed in there, I'll click Start. Now I'm just going to wait and look at the traffic, and here I can see some ARP communications. Now let's start working with display filters. Now in the Wireshark Network Analysis book, you'll see that display filters have their own chapter, chapter 9, but you'll also see that I have display filters in so many of the other chapters, such as the Voice over IP chapter, the Wireless LAN chapter, the HTTP chapter, showing you how you can build display filters for that specific type of traffic and error conditions related to that traffic. There's so much. I'm not going to go through too much about display filters in this quick video, but let me just show you some of the key things you can do with display filters. I was capturing just a moment ago. I cruised out to the ESPN.com website and I captured some traffic, and it's all sitting in a temporary file. We can see that down by the status bar area. If I'm interested in just taking a look at the DNS traffic that was generated during that web browsing session, you can see that I just typed in DNS in the display filter area. When you type in something and you end it with a dot, it will show you what your options are to continue adding to your filter. Maybe I'm just interested in packets that have a certain DNS flag setting. In that case, I can choose DNS.flags and finish it from that point on. So this is the autocomplete feature. You'll also see that it has color coding in the background. Red means this filter will not work. Green means this filter syntax is correct, doesn't necessarily mean it's totally logical. Yellow is a definite indication that this may not give you what you expect to see. The most common problem people have with filtering is with IP ADDR. When they're filtering for certain traffic, so let's say we do a filter for all traffic to and from 192.168.0.106. This is the syntax. It's a different syntax than we use with our capture filters. So we know the syntax, and then when we want to do something called an exclusion filter, where we say we don't want to see traffic to or from that address, people know that there's an exclamation point that you can put in there. You can say not equal to, but this is incorrect syntax, and you can see by the yellow color coding that Wireshark is trying to warn you. So watch out for that one. The correct way to do that would be not IP ADDR == and 192.168.0.106. That would be the correct way to do that. Let me go ahead and just clear out that area. We can do very simple right-click filtering, so I could open up a packet, look inside, and this is an SLP packet. I want to see all of the attribute request SLP packets. So I'm going to right mouse click and just say I want to apply a filter based on that selected value. Now all of the packets that I should see after this will be SLP packets that have the attribute request function in them. And there they are. We can see the syntax up here in the filter area, and if I like that, I can click the filter button and save that as a new filter. Display filtering is used not only to help us with the needle in the haystack feeling, sort of pull out certain parts and pieces of our traffic, but we also use that when we do our I/O graphs. We can place a display filter into our I/O graphs, and we use the same syntax with our color filters. I'll clear this filter out. What if we have to build a filter on something and we've never even seen the packet structure? We don't even know what it could possibly be. In that case, the expression button is a nice option. When you click on the expression button, Wireshark brings up a list of fields that it recognizes. So if I have to build a filter on, let's say, mobile IP traffic, and I've never seen it, I can type in mobile IP, and there it is. Just by selecting that line that says mobile IP and having the relation set to is present, I would now be creating a filter looking for just mobile IP traffic. I'll apply that, and we have no mobile IP traffic in the trace file, so we should end up with an empty screen, and we do. I'll clear my filter again. With Wireshark, we also have the capability of preparing a filter but not applying it yet. So I'm just going to go a little further in my trace file here. Let's see, I'm going to go down to where, there we go. We have a TCP communication. And I want to build a display filter that will show me all of the packets that have a window size less than 1460 bytes. And you know from the Wireshark network analysis book why 1460 is such an interesting number to watch for. So I'm going to do a right mouse click filter, and I'm going to choose prepare a filter. I'm not going to apply it, I'm going to choose to prepare it based on the selected value. Now I want to change this filter, so I used prepare just to put the information up there, but I'm going to say I'm looking for packets that are less than or equal to 1460. Oops, 60. There we go, and I'll apply that. Now I know that I would see a small window size on any TCP reset packets, and these are reset packets. So I'm not interested in those packets. I want to filter those out of my view. So I'm going to expand the TCP header flags area, and there's a packet with the reset bit set, and I don't want to see those. So I'm going to right mouse click and prepare a filter, and I'm going to say and not selected. Now using prepare a filter allows me to look at my filter before I apply it, so I can make any changes if they're necessary. So I'm looking for any packets that have a TCP window size less than 1460 bytes and also do not have the TCP flag setting. I'll apply this, and what's left is a curious set of packets that would be of concern on a network. Display filters are extremely powerful. They really allow you to pull that needle out of the haystack so you can focus on just one area of the network communication. And again, there are so many areas in here where display filters are used. Make sure when you go through the book and you see some of the display filters that I show you, like let's say the wireless LAN retries, build those and save those in your display filter list so you can use them at a later date.